Hey everyone, welcome back. So in the previous video, we have learned about the Kubernetes pod lifecycle and 5 phases of the pod. But in the real environment, when you run kubectl get pod, you will see the status like CrashLoopBackOff, ImagePullBackOff, CreateContainerConfigError, and out of memory killed, and many more. So in this video, we will understand what does each pod status means, why they occur, and how to troubleshoot them, and we will also perform hands-on on it. So let's get started. As the first status, we have a container creating. And the container creating means Kubernetes has accepted the pod and it's preparing to run. And during this phase, Kubernetes is doing three things. It's pulling the container image, attaching the volume, and configure the networking. And you will see something like this. A common example, when you deploy Nginx pod, Kubernetes is still downloading the image and setting up the container. The next status, we have a crash loop back off. The crash loop back off occurs when the container started, but it crashes again and again. So Kubernetes keep restarting the container, and Kubernetes gradually increase the wait time between each restart attempt. A common example is when application is trying to connect to the database, but the connection fail and the application then stop and Kubernetes keep restarting it. And third, we have a ErrImagePull. And the ErrImagePull means Kubernetes is trying to pull the container image, but it failed on the first attempt. And this usually happens when the image name, tag or registry credentials are incorrect. And you'll see something like this. A common example is when the pod is configured to use the image, but that does not exist. Next, we have an ImagePullBackOff. ImagePullBackOff means Kubernetes cannot download the container image and keep trying again and again. Usually, it starts with ErrImagePull, and after that, Kubernetes wait for the few seconds and retries. If it keeps failing, the status will change to the ImagePullBackOff, and you will see something like this. A common example is when the pod is trying to download the image from the private container registry, but the Kubernetes does not have a required credential to access it. The fifth status, we have CreateContainerConfigError. A CreateContainerConfigError means there is a problem with the pod configuration, so Kubernetes cannot start the container. And the most common reason is the pod is trying to connect to the secrets or config map that does not exist. And you'll see the status is equal to CreateContainerConfigError. Example, when the pod expects a secret called dbSecret, but the secret has not been created, since the Kubernetes cannot find it and the container cannot start it. Next, we have a out of memory killed. And OOMKilled stands for out of memory killed, and this happens when the container uses more memory than its configure limit, and the operating system will kill the container to protect the node. And you will see the status like this. For example, a Java application has a memory limit of 512 MB, but try to use more memory. A container get killed and Kubernetes restarted. Next, we have a completed. Completed means container finished the task successfully and exit with exit code 0. And this status is commonly seen with init container job and cron job. And you will see the status something like this. A common example, a database backup is run successfully and exit after creating the backups. Next, we have a terminating. The terminating means the pod is being deleted. So before removing the pod, Kubernetes gives some time to shut down the application properly. But by default, it waits for the 30 seconds. And if the application does not stop within the time, then Kubernetes will forcefully stop it. And you will see the status like this. For example, when we run kubectl and delete pod and pod name, Kubernetes start deleting the pod and change the status to terminating. Next, we have a evicted. Evicted means Kubernetes remove the pod from the node because node was running out of the resources such as memory or disk space. And you will see the status something like this. Common example is when the node runs on low memory. To keep the node healthy, Kubernetes remove the pod and marks them as evicted. So for each pod status, we will use simple YAML file to create the condition, and we will check the status, and then we will learn how to troubleshoot it using common Kubernetes command. So open the killercoda.com and select the Kubernetes playground and wait for the environment to load. So once it is loaded, verify the cluster and verify with kubectl get node, and you will see the node are in ready state. So let's get started. So let's check the first status, that is container creating. So let's create the YAML file. Press -i and paste the YAML. So this YAML file create the Kubernetes pod and run the container using latest Nginx image. Press W: to save the file and exit. So let's create the pod and watch the status. Now you will see the container creating and then it moved to the running. Kubernetes pulling the Docker image in the background. Now Ctrl+C to stop the watching and delete the pod. The pod has been deleted. Now let's check the status for the CrashLoopBackOff. And for this, we will create a YAML file and press -i and paste the YAML file. So in this YAML file, container is configured to run the command exit1. The container exit as soon as started. The Kubernetes try to restart the container again and again, and the pod eventually show the crash loop backup. Save and exit from the file. So let's see in action. And now let's check the status. And you see the crash loop backoff. We can delete the pod for the cleanup purpose. Now let's check the third status, error image pull. And we will create a file again. Press -I and paste the YAML file. So in this YAML file, we have used wrong image tag. Since the image tag does not exist, so Kubernetes cannot pull the image, and the pod will show error image pull status. So let's see how it works. Now let's check the status. It is showing as a container creating. Let's wait for a few seconds and check the status again. And you see the status error image pull because image tag 12345 does not exist on the Docker Hub. So let's troubleshoot this pod and look at the event section, and here you see nginx 12345 not found. Now let's see the status for ImagePullBackOff, and let's check the status again. And you will see the status ImagePullBackOff. So what is happening here, if you provide the incorrect image or tag, the pod first show the status error image pull because Kubernetes cannot pull the image. But Kubernetes try to pull the image again and again, and after a few seconds the pod status will change ImagePullBackOff. Now we can delete the image. The image has been deleted. Now let's check the status for CreateContainerConfigError. And to do this, we will create a YAML file, and we will copy and paste the YAML file from here. So in this YAML file, we have given a secret reference, but we have not created the secret yet. So when the pod start, it tried to find the secrets. Since the secret does not exist, so the pod failed to start. So let's see in action and create the pod. So we have created the pod, and let's check the status. And it says CreateContainerConfigError. Now let's troubleshoot this pod. And you see the error here, my secret not found. Now we can delete the pod just for the cleanup purpose. And we will set the next status as a out of memory killed. Again, we will create a file here, and then we will type this YAML file. So in this YAML file, container is limited to use 50 MB of memory, but the application try to use 100 MB of memory using the stress command. So as soon as it reaches to 100 MB, Kubernetes terminate the container, but the container keep restarting, and the pod eventually shown as a out of memory kill status. So let's create the YAML file and check the status. Now let's check the status. Let's check the status again. And here you see the status is equal to out of memory killed. Now we can also describe the pod to check more in detail, and scroll to the container section. And here you see status is equal to terminated, reason is equal to out of memory killed, and status code is equal to 137. Now we can delete this pod. Now let's check another status called completed. And for this we'll create another YAML file. So this YAML file will create the Kubernetes job, run the Kubernetes BGBox container, and print the hello Kubernetes, wait for the 2 seconds, and then exit. And it does not restart after the completion. So let's save and exit, create the job, and then check the status. And you see the status is equal to completed. We can also describe the pod. And you see the exit code is equal to 0. Let's clean up the job. Let's see the terminating state, and we will also create the YAML file for this. So in this YAML file, we will create a pod, and when you delete the pod, Kubernetes allow to shut down the pod and then remove it. So let's see. Now let's check the status, and it is running. Now let's delete the pod and watch at the same time, and you see it is terminating. Next we have a evicted. Evicted means Kubernetes removed the pod because node ran out of the resources. We cannot trigger the evicted status easily in this lab, but here how you can find it, the evicted pod, and you see we don't have any evicted pod in this node. So let's quickly recap. So first we have a container creating. Kubernetes is preparing the container to start. Then we have CrashLoopBackOff. Application keep crashing and restarting. ImagePullBackOff. Kubernetes keep retrying to download the container image. CreateContainerConfigError. Secrets or config map is required. OOMKilled. It means container used too much of memory and it was killed. Completed means job has successfully completed. And terminating means that the pod is being deleted. And then we have a evicted. Evicted means the pod was removed because node ran out of resources. And we have a few useful commands to troubleshoot the issue. So that's everything about the pod status. In the next video, we will learn about the resource request and limit in the pod. If you have any questions, feel free to ask in the comment below. Thanks for watching, and I will see you in next video.